Okay, question 16. Consider the following statements. If f(x) is an integer for every integer x, then f prime x differentiated is an integer for every integer x. Which one of the following is a counterexample to star? Okay, so classic TMUA question, right? You're finding a counterexample to an if-then statement. Yeah. So how do I find counterexamples for an if-then statement? What you do is that you need to make sure the if condition is satisfied. So this guy must be true, and then this guy is false. Yeah, this is a counterexample. Okay, so we need to find something where the if condition is satisfied. So for example, option A. Is this an integer for every integer x? Well, not quite, right? The obvious example being x equals to 1, right? If x is equal to 1, then 1 plus 1 plus 1, that's 3. 3 divided by 4, well, that's clearly not good. So A is bi. Right? Okay, how about B? Same logic, right? If you put you put in x equals to 1 and then you're screwed again, right? 3 over 2, that's not an integer. So B, gone. Right? Okay. How about C? So C is more interesting. I think you can factorize C even. Right? So could you factorize C? So this is x times x cubed plus x squared plus x plus 1. So this is what? X times x squared plus 1x plus 1. Right? The classic factorization. Good. So you see you have x and you have x plus 1, right? So that's definitely okay, because if x is even, then x plus 1 is odd, right? It's divisible by 2. If x is odd, then x plus 1 is even, right? So it's also divisible by 2. So that satisfies the if statement. So C is okay. Yeah. How about D? So D, again, there's factorization up there. So x squared times x plus 1 squared, right? So again, if x is even, okay, fine. It's divisible by 4. If x is odd, well, then x plus 1 is even, right? So you have even squared, which is divisible by 4, right? So D also satisfies the if statement. Now what we're going to check is the second guy. Yeah, we need to make sure the second guy is false. So off we go. We need f prime of x. Yeah, we need f prime of x for these two things. So what do? We differentiate f prime x equals, so this guy over 2, 4x cubed plus 3x squared plus 2x plus 1. Sweet. Okay, next guy. The guy down there, f prime x equals 4x cubed plus 6, what's this, 6x squared, right? Plus 2x over 4. Okay, so any integer x makes it false. Well, for example, option C, if you pick x is 0, then you're sort of screwed already, right? If x is 0, then the thing becomes 1/2, right? So then that's not very good. Yeah, that makes sure that the then statement is false. Yeah, so that's why C is the answer. Yeah. Well, can you prove that D is always an integer? Well, there must be some fancy factorization that I can't see right now. Yeah, but I know that C is a counterexample, because when you sub in x is 0, so why is C a counterexample? Because when x equals to 0, f prime x is not an integer. Yeah, that's why it screws up the then statement. Yeah. So answer is C.